As you can see, you guys have managed to buy a solid day of developer time for jofito in under 24 hours. I am truly humbled by your support. In fact, I am so humbled that Danny the dinosaur back here has now decided to become my high priest, which is why there's that creepy staff thing that I'm a little afraid of. Anyway, in order to avoid getting murdered by the magic, I'm going to show you what I've done, just so that you can understand jofito a little better. I have this nifty little diagram right here. Oh, no, Danny, please don't kill me for hiding you. But this is how we're going to beat Rust. It's pretty straightforward if you know what you're looking at. So let me maybe pivot somewhere else, which is going to unfortunately force me to edit the video, and actually show you this diagram in a little bit more clarity. All right, this is going to make for the most awkward presentation I've ever given anyone ever. So what we've got here is the old way of doing things. This is your standard pipeline. By the way, excuse the stacking everything up on VCRs. I didn't know what else to do. I don't have a proper table here. Find dot dash type F pipeline to grep dash E, the backslashes are escapes for the dot, JPEG $ dash E backslash dot PNG $. Now, what does this mean? Well, if we try to read it like a layman, it doesn't mean very much. Find whatever an F is. I can think of some things that start with F that remind me of things that I don't want to find. But anyway, and then a vertical symbol. And what is a grep? Who knows? And what are all these? I mean, I kind of know what JPG and PNG mean. But if I'm a layman, this is cryptic crap. It's not just cryptic, it's inefficient beyond belief. So here's what we've got. You'll notice that we have arrows going down to this box called pipe buffer. That's because if you run find, current directory as the root for the find, only return results that are type file, just as an example. Pipeline, it has to shovel the output of that as the input of grep. Grep is general regular expression parser. It's a big fancy state machine that takes a while to spin up and is not all that fast at just simple globbing, which is the term used to refer to finding basically finding substrings in a string except in reverse. So these grep expressions, which is the E's, say .jpg or .png, and $ is code for the end of the line. And you have to know all of that to make this work. This essentially finds every single file, but not directory, only actual files, under the current directory, and then pipes that to grep to then further reduce the results so that you only have JPG or PNG file extensions at the end of the list. To do that, it has to jump through this pipe buffer. Now, the problem is some data will get kicked out of find, put into this intermediate buffer, and then pushed out of the intermediate buffer as the input of grep. Every single time you send stuff through a pipe, or a consumer consumes the stuff through the other end of the pipe, you have a context switch. Also, I didn't illustrate it here, but you also have a problem where if the consumer isn't fast enough, the producer waits for the consumer, potentially running into a nasty time-sinking task of some sort along the way. But we're going to ignore that for now. So every time you do a context switch, you're basically throwing away your CPU state and trashing your caches, which makes everything run slower, because now all this stuff you're doing the work for here is no longer in main memory, or rather in the L1 cache, which is your CPU's execution core's main memory. It gets thrown out and switched over to this one. You just keep bouncing back and forth or whatever. So you're destroying your cache coherency by duplicating data, because the pipe buffer doesn't just like magically drop itself into grep. It has to be fed through the interfaces that grep uses to input, be it fget_s, which reads individual lines, or fread, or just plain read. But one way or the other, it gets kicked out of this, which usually there's some kind of output interface here, Then it gets stored by proxy in a buffer. Then that same proxy is also kicking it out. So there's all these switches between the contexts, and it wrecks your CPU performance. Now, it's also just generally inefficient and unreadable. Grep is also a beast. And at the end of it, all we're doing is printing the list of files that match. Now, my solution, jofito, Jody's file tool. We'll say scan directory. And this is sort of the C function format. I'm sorry I had to break things across lines because I wrote large, but it ends over here. So scan directory, the first parameter is the same thing. It's dot. It's presented in double quotes so that we know it's a string. We know that it's actually meant to be text and not a variable name. That's important. But other than that oddity, this is the same. But here's how it differs. Find does not have grep. Find can't do the only match things against certain parameters or only match things that don't meet certain parameters. Scan directory, however, has this curly brace filter that ends over here. Filter is a generic predicate that calls a particular kind of filtration on a string or a list of strings and then filters them as you want them. In this case, we would have a filter that filters extensions, JPG and PNG, corresponding to JPEG and portable network graphics images. It's much easier to read. We know we're scanning a directory. The dot's cryptic, but it's the current directory. I mean, that's just, you kind of have to accept that degree of the terminology here. Excuse the coughing. Then this filter, what happens under the hood is scan directory alone can just start reading the directory contents, but filter runs in a parallel thread. And then you'll notice that's not the end of it. Then the last one is another predicate called print. The curly braces mean that it's a predicate. Basically, think of it as a modifier. And that's the end of the scan directory function. Now, we don't have to have a big pipe buffer. We don't have to have an output buffer, a pipe buffer, and an input buffer, which is what's really going on here under the hood with the C library. Instead, we're doing everything in-house. We do it all internal to jofito. So what we have is an arena. An arena is a kind of memory map where you just slam everything in order and you allocate it in large chunks. And I don't want to go too far into it, but the bottom line is, as the scan directory reads in these paths and stores them in the arena here, the filter predicate is chasing that arena. Rather than waiting to be able to continue to scan the directory for the filter to make a decision, these run in parallel. If scan directory is faster than filter, then filter eventually has to catch up. But if filter is faster than scan directory, which is most likely, then filter catches up to wherever scan directory is and stops. It just stops. It doesn't process anymore until scan directory increments the size of this list. And that triggers filter. Its thread wakes up, sees that the increment's there, sees that the done flag for the operation it's supposed to filter hasn't been toggled, and bumps to the next item. So in this way, we have a leader and a chaser. The chaser goes through, and that's what this blue arrow is here, and qualifies each one. This one's bad. Okay. So what happens when filter finds this bad one? Scan directory has already moved past it. So filter will deallocate this and detach it. There's a complicated way that I prevent deallocation of an object from the arena from causing an index mismatch, but it can, all you need to know is that we can remove this item without the third chaser or the second chaser print here having a problem where, oh no, there's an item that's gone and now I see this is item 3 instead of 4. We don't have that problem. Filter can immediately detach this. And now when print goes through, it will never hit this. See, each one of these follows in order. This is the most subordinate. This is the leader. So print is chasing filter, is chasing scan directory. We have a situation here where if you have 3 cores or threads on a machine, the directory scan can be happening, and this actually would be happening in bulk with some of my optimizations. Then the filtration of that scan will be happening in another thread or on another core at the same time, and will stop when it runs out of data and resume when more data is available. Then the subordinate here also, same deal. It will stop when the filter doesn't have any more filtered items available and continue when it does. So scanning, filtering, and printing can all happen on a modern machine with multiple cores simultaneously. But the most important part is, if we have the scanner, the filter, and the printer chasing, all one after the other, the likelihood of, say the scanner here has just loaded bad.txt into the list, and then the filter here has filtered just qualified abc.jpg, and the print has just printed xyz.png, right? So these things are all, assuming that the predicates here are fast enough, they're all kind of working in lockstep, which means that these items are still hot in the level 1 instruction and data caches as it's iterating through this list. So rather than this situation where you have 3 separate lists that are in completely different places that are blowing out each other's L1 cache presence, our entire chain here is following one another. And the best part of all of this, which, other than the fact that print can output immediately instead of waiting, the best part is this part. Arena objects are destroyed once they're terminal. So, what makes an arena object terminal? Well, when filter filters out this, it can no longer be passed to any of the predicates that are subordinate to it that come later. So, print is not going to be able to print this, so there's no more use for it. This object officially is dead. So filter can say so. Filter can say, hey, this one's a no-no, kill it. And it gets killed, and it gets marked as free in the arena. But then, when print prints this one, and this one, and this one, and this one in order, as it's printing them, it is the terminal predicate. It is the end of the line. Nothing happens with this after print because we didn't assign the scan directory results to some variable to keep. So once scan directory is done and print has completed, we don't need any of this anymore. But we don't deallocate it in bulk at the end. As print chips away at the list and is the tail end of this predicate chain, dump, 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 dump. Once an item is no longer needed, it is freed up. Once enough arena items have been freed up, this entire arena page can be compacted. And I don't want to go over it in this one, but maybe in the next video if you're interested. The way that the arena works is we actually have an indirection block. Think of it as over here somewhere. So that these high-level primitives point to indirection blocks, but the low-level locations are pointed to by the indirection block. So this sees the list it's outputting at a fixed location that points to a variable location. So we can move these around all we want. We can garbage collect, as in free up memory and compact out the empty spaces all day long. And none of these predicates or filters or actions or verbs or whatever you want to call them have any idea that that's going on right behind their backs. Anyway, this is just a basic example of the kind of thing that I intend to do. This effectively replaces this find grep chain, which is a pretty common one. I actually use this pretty often to find all of the pictures under a certain folder. So this is not some academic example. This is real world, working with your hands on the metal, system administration. I need to find all the pictures underneath this folder and get a list of them. And this is a common thing to do, and there are steps along the way that make it a lot slower than it has to be. The longer you wait for one step to finish, the longer it takes everything down the pipeline to finish. Also, something I haven't talked about, maybe a little teaser for you guys. I want to replace find and grep with jofito primitives and scripts. Well, one of the solutions I have to, well, how are you going to integrate jofito in like this and not lose the benefits of avoiding this pipe buffer? I've come up with some tech called pipe coalescing, where find and grep see they're part of a pipeline. Find and grep see they're the same jofito executable. And then find is the head, so it's the coordinator. And all the subordinates down the pipeline reach out to the head and say, hey, here's my script, here's my parameters, integrate me into you, and I'll just become a hollow pipe that sends the final results down the line. Thus, find and grep and sort and unique and whatever else your big, long, stupid pipeline might use all get collapsed by jofito, if they're all jofito scripts instead of the actual binaries, that is, into one unified jofito script in memory that then performs all these actions and thus can optimize away cases where, for example, it would be wasteful to get certain information. It can optimize away that stuff and do it faster than you would ever be able to do it with a normal pipeline on your own. Anyway, I don't want to talk anymore. I know I've hit almost 15 minutes on just this part, and I thought that this would be a good introduction to give you an idea of what we're doing here and why you funding jofito development is so important. This kind of logic is not something that just anybody can write, and even for me, it's not like this is necessarily easy. This is a lot of work and a lot of testing. So, look down. My Ko-Fi will be in the description, possibly the pinned comment. A link to the video that started all this, perhaps too. And thanks for your support. I hope to do you proud. Have a great day.